right, the first thing we need to talk about is rational exponents. So,
wait, are we? I want to learn. I want to know.
Rational exponents. The top is your power, the bottom is your root or your index. So the top is my exponent. The bottom.
You guys made this a mess.
No one cares, Will.
So I'm writing this as rational exponent. So it'll be 25. The top is the exponent, so 4. The bottom is my root or index. And that's your answer. We're just rewriting it an exponential form. Exponential means as an exponent. On number 1 that you're doing, it's always raised to the first power. So make sure you know that.
Wait, so then rewrite the expression using radical notation. You just go back to the first form?
Yes. On 4, we're going backwards. So it gave you, it is exponential form, and I want you to write it in radical form. The bottom, is that 5? Oh, that's no, in yours it is. He was looking at her. She was looking at hers. You can put the first power there. You don't need to.
Okay, that's not bad.
On number 6, again, I'm doing odds. I'm evens. I have a negative exponent. Negative exponents mean it's not happy where it is, so it's going to drop to the bottom. Square root of 4. I'm going to make one more step. So to get rid of a negative exponent, it goes to the bottom of the fraction. Then to simplify it, write it as a radical. And then take the square root of that. So the rule I'm using here is that if it is a negative exponent, it goes to the bottom to become positive.
So the 1/2, whenever you do that, it doesn't matter whenever.
All right, on 8. We just learned 8 yesterday. Square root of -1 times the square root of 100. Square root of -1 is the definition of I. And then the square root of 100? 10. 10i.
Oh my gosh, my stuff.
Thanks. Like 2 minutes late. It's okay. Well, that's what she's doing.
27, you're taking the cube root of 27, negative 27, and raising it to the 4th power.
What's Einstein's theory of matter?
Oh, number 7.
I'm doing 10. I'm doing 10. 10, they are like bases.
I don't know how to do them.
So I add my exponents. So I'm going to add 3/2 plus 5/2.
Yeah. Duh.
Yeah.
So I will get 8/2. 3 plus 5, 8. 8 divided by 2 is 4. So 4 to the 4th power. What is 4 times 4 times 4 times 4?
6.
No.
256.
In a calculator?
Hey, I got 6 back.
256.
How did you know that?
Mental math. Used it. Yeah.
16 times 16.
I was doing it in my head. I did 4 times 4, 16. 16.
On 11, you're raising a power to a power. You will multiply your exponents.
Yeah.
Multiply exponents.
Wait.
My 6th grade idea.
What?
Get out.
I want you to, when you have a like term on top and bottom, you subtract your exponents. So 5 to the 1/8 minus negative 1/8. So top exponent minus the bottom one.
Are we supposed to do 10?
I hope so.
It was all for you, and I paid you so you could get motivation to go.
I don't remember.
We'll go with it. I'll take the place.
I'll just, yeah.
She wish she didn't have motivation to go now.
When you add fractions, remember you add across the top. So 2/8.
Because she's a trash person.
2/8 can simplify to 1/4. Write it in radical form. Fourth root of 5 to the first power. You don't have to write the first power.
So her saying that on top of me really not making
This one is okay. It's the
Or
I
I'm
don't understand.
I think you misread.
No,
Or
I'm
stop.
I mean, about 10.
Oh my gosh.
What about 10?
Yeah.
All right, on 14, we are going to go from radical to exponential back to radical. So this is 3 to the 1/2 times 3 to the 1/3.
Oh, it was on the part.
Huh? This is the square root. So there's a 2 there and a 1 there.
Did you not like
And then again, you add your fractions. When it's blank, it's square root, yeah. The most common one is square root, so that's why they just start leaving off the 2. 1/2 plus 1/3 I can't do because I need common denominators. You got a calculator, you can put 1/2 plus 1/3 in your calculator. Or you can get common denominators of 6. So you'll get 5/6.
Why'd you call me? I can't do that right now. I have to make sure that I understand.
And then the bottom is your radical. The top is your power. Yes. And you can simplify it by doing 3 to the 5th power. It's like 3 times 3 times 3 times 3, 5 times. But you couldn't, you'd have 5 3s, so you couldn't group them in 6. So you can't simplify that anymore. So
On my test, can we just leave it how it is right now?
yeah, that's fine. I'm just gonna put it in there.
But all the even ones are easier than all the others. How are we supposed to figure it out?
They're not easier, I promise. All right. These are both the square root.
I got one more. We have 3. She keeps 3.
When you have both the same square root, multiply them. So I get the square root of 100. And that's 10.
I always ask you. You don't say anything.
Will ask me and then when I explain, somebody else starts.
17's distributing, FOIL, whatever you want to call it.
I just don't want to.
So 16 would just be 10.
I mean,
Yes.
that's just weird. And then she stays with them after she-
18
That's a good reason why I don't
is a negative exponent. So I drop it to the bottom.
You don't know what someone else just said. Not that I know of, I don't talk to all of them.
To make it a positive 1/3.
I stopped when I figured out how he was.
But a fraction and a fraction's ugly.
Yeah, I didn't know.
So it's better to multiply by the reciprocal or flip it. So that's 125 over 8 to the 1/3. Miss Rhodes? Yes. Sure. Jamie, Mr. Bertolo wants you in the front office. Yep. And then 1/3 is cube root. So we're taking the cube root of that. The cube root of 125 and the cube root of 8. Breaking down 125. 125 is 5 times 25 and 5 times 5.
Man, I liked math before this. I never liked it. I've never liked messages of him saying, yeah. I was good at math.
8 is 2 times 4.
I know.
4 is 2 times 2. Every 3, 1 comes out. Square root every 2, 1 comes out. Cube root every 3, 1 comes out.
Oh, that's cool. I was with my friend first of all, and that was weeks ago. No, actually, it was months ago. It was right now. I blame her for saying someone who's like that.
Are we doing the?
Tell me.
16 times 2. Yes. Or break them down using your factor tree.
I mean, that's essentially what I'm doing in my head.
Yes.
I never went out of my way, except for that one time that happened months ago.
Every 2, 1 comes out. Every 2, 1 comes out.
Make her uncomfortable. I stopped doing it for that.
You're right.
Why can't I ask you? I didn't change, but you're not excusing how I feel. When I see a problem, I walk away from it. I make it known.
5 twos.
That's why I have my friend now.
So 10 square root 2 minus 4 square root 2. These are like terms. They're both the square root, and they both have an index of 2. Radicand of 2. So you add their coefficients. 10 minus 4, 6.
Not my 2-year overdue library book. I don't like her. Like the other day, I was talking to Olivia about when you get home and wrote your journal, I go, I don't like you. So she shut up. I thought you were going to say
All right, when you're rationalizing, you're getting the radical out of the denominator. If you're not paying attention to me, that's up to you, but stop talking. We're rationalizing, we're getting it out of the denominator. You're going to multiply the top and the bottom by that denominator, by that radical that's in the bottom. So just to give myself some more room, I'll do it up here. Multiply the bottom and the top by that same radical. Because then you'll get 2 square root 3. Remember, you can only multiply if they're both inside the radical or both outside the radical. So the top, the 2's outside and the 3's inside, so you can't multiply those. But on the bottom, they're both underneath the radical, so you can multiply those, which is just 3. Which is the whole purpose. The radical is now out of the denominator. You're done. The last step you need to look, though, is that the 2 on the outside and the 3 cannot simplify. If this was 6, then it would simplify.
Melissa?
24.
Wait, I didn't. Can you go up a little bit?
We already broke down 125. It was 5 times 5 times 5 from earlier up there. And that's x to the 6, so we have 6 x's. And again, cube root. Every 3, 1 comes out. Every 3, 1 comes out. Every 3, 1 comes out. Yes. Nothing's left under the radical. 5x squared.
It's time to go. We have 3 minutes until 12 o'clock.
Okay.
For real, I got excited for this. I was like, no way.
All right. All very wordy, but I'm just asking you to look at the first equation and say, what's your transformation? So, very wordy, but we're just looking at this first equation. -6, how's that going to move my graph? Down 6. It's down because it's outside my radical. Outside my radical is up and down. If you're outside, you can go up and down. Great.
Is this what we did?
Can you move back there? I should have said that a long time ago.
Is this what we did at the beginning?
This is what we did last chapter in parent functions, and then this was Friday's work, last Friday's work as well.
That's on that one?
All right, 28, you have a negative in front of the radical. A negative in front of the radical reflects over what? And then we have -2 on the inside of my radical. Left or right? Right 2. You had to plug in a +2 to this equation, so that's why it's right 2. So you really need this equation if you don't have that already. All right, 30. We're graphing. +1 inside the radical is going to do what? Left 1. And outside the radical, up 1. You need to know your parent function. Your parent function is your square root. And what numbers do we plug in for square root? You forgot your the first one. 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. You can plug in any points. You have to start with 0, though. You can use your decimals. But these are the ones you get nice whole numbers with.
This is one of those tests where if I use my notes, I'd still fail.
And we're moving it left 1, up 1. So you can just take those points and move them left 1, up 1, left 1, up 1, left 1, up 1, and have your new graph. Or you can move your table left 1, up 1. So if I'm moving my x values left 1, I'm subtracting 1. So 0 is going to become -1. 1 is going to become 0. 4 is going to become 3. And 9 is going to become 8. That's left 1. I moved all my x values left 1. And then I moved all my y values up 1. And so those are the points I graphed. -1, 1. 0, 2. 3, 3. 8, 4. You don't have to graph both the original and the transformation. It just helps to see the original. With your domain and range, I want it of the new one. The transform, the actual equation. So start on the left, working to the right. My first point is -1. Going on forever to the right, positive infinity. Starting at the bottom, working way to the top. +1. Our y values are +1 to infinity. Going up forever.
Are the evens going to be from?
All right, I'm going to switch and do 33 because that's a cubic one, so you can at least see both of them. Remember your parent function? Whoops.
You drink some water.
And our perfect cubes. 0 goes into both of these. 0, 1, and 8. And you can do negative numbers for cube root. A negative times a negative times a negative is a negative number. So the cube root of negative 8 we're doing 33 is negative 2 because negative comes out of a cube root. Might be confusing with y right there. We don't need the y. And then 8 is 2 times 2 times 2. So negative 2. Hopefully you just memorized those though.
No, I thought we were done with them, so they left my brain.
Get them back.
I didn't, none of it went in my brain in the first place. Okay, I'm gonna follow this. I'm by barely. Why'd you waste it?
You want it?
Yes. Hey, can you stop the couch?
2 on the outside, how's that going to affect my graph? Vertical, stretch. Ignore that. By 2. And then minus 4 on the outside, down 4. Vertical, is that X or Y? Y. So that's going to affect Y. Down, is that X or Y? Y. So X's aren't going to change. My X's are going to stay the same X values. Only if you're moving left or right do your X values change. Y values are going to be multiplied by 2 and then move down 4. Minus 4. So I'm going to take negative 2, multiply it by 2, and move down 4. So that's 2 times, negative 2 times 2 is negative 4. Minus 4 is negative 8. That's a long, complicated way to do it, or you can just plug it into your calculator. You're going to be doing 2 cube root of negative 8 minus 4. And I just put that in my calculator and get negative 8. I plug in negative 1. Negative 6. I plug in 0. Negative 4. 1 times 2 minus 4. Negative 2. 2 times 2 minus 4. 0. So it's moved down 4 and stretched by 2. What is the domain and range of cubic? Infinity. Negative infinity, positive infinity. Don't just put infinity because it's going negative as well. You could put your real numbers, capital R, with an extra leg through it. All right, that's halfway through the review. We're going to stop there for today. I want you to work on the evens with each other and me right now.